All right, question 24. A study was conducted that resulted in the following relative frequency histogram. Determine whether or not the histogram indicates that a normal distribution could be used as a model. So looking at this histogram, it looks skewed to the left. So since it's not roughly normal, we're going to say that we cannot use the normal. Histogram is bell-shaped? Nope. Histogram is not bell-shaped, so a normal distribution could not be used as a model. Histogram is not bell-shaped, normal distribution could be used. Histogram is bell-shaped, normal distribution could not be used. So B is what we want. There were no more parts there. Let me make sure. This one part. Okay, 25. Graph of a discrete probability distribution. To the right represents the number of live births by a mother 42 to 45 years old who had a live birth in 2015. Complete parts A through D. What's the probability a randomly selected 42 to 45-year-old mother had a live birth in 2015 has had her fourth live birth in that year? So this is 0, 1, 2, 3, 4. The probability she had her fourth one is going to be 0.112. So just following the table. What's the probability a mother who had a live birth in 2015 had her fourth or fifth live birth in that year? So this time we're going to add 4 and 5. So I'll add these two columns together. So 0.112 and 0.105. Actually, we just get 217. So 0.217. Just adding those. What's the probability a mother? Let me see if I can just make this bigger. So what's the probability a mother had a live birth in 2015 had her sixth or more in that year? So 6 or more. That'd be 6, 7, or 8. We're going to add the probabilities of 6, 7, and 8. 0.032, 0.039, 0.059. Adding all those, we get 0.13. And then D, probability, okay, if 45 had a live birth in 2015, randomly selected, how many live births would you expect that mother to have had? How many would we expect? So the expected value, basically the peak, the highest point is going to be your expected value, that'd be 2. You can get that by finding expected value, number times the probability, add them all up. So we could do that, but usually it's the height is your expected number. So we would expect her to have 2. Alrighty, we're going to submit. And then we'll talk about any mistakes if possible. So there are 2 errors. We're going to look at these 2. Might have been the expected value since I didn't compute it. So let's look at 23. This one is what we picked. It said it will not be appropriate to interpret the slope or the y-intercept. And maybe that's because it wasn't linear. I would need to go back and look. But we answered B, and they said it's not appropriate to interpret the slope or the intercept. So if it's not a linear model, if it don't fit, then that would be the case. Okay. So that one I would have to go back and look at a little bit more. And then the one we missed on 25 is this one. So yeah, probably want to go and actually compute the mean, which each value times its probability, add them up. So when it's normal, yes, the mean will be the highest point. But since it's not normal, this looks skewed to the right. That means it's going to pull the average to the right. And I do know that, but I didn't think to do that at this point. So if we multiply 1 times 2.31 and add that to 2 times 2.59 and do that with each number and its probability all the way down, add them up, we'll get the 3.1. Okay, so otherwise everything else is good. So hopefully this review will help you out. Your test will be of similar format. The numbers will be different. The order will be different. You can omit the 2 Poisson problems. You can do them. I will just curve the test according to their weight.